Okay, we are live, guys. Hi all, this is Vasa. I'm going to share the link in order you to come on YouTube. Mhm. Yes, it is. Here's the link on our Telegram group. Please, for comments, please go right on YouTube. Okay, so let's wait for 5 minutes and then we can start. Let's see if someone will come up in order to not stay in silence. What we'll see today, I want to share with you all the work that I did this week. It concerns, as we said, the creation of the organizations. I wrote recently a message on Telegram where I said the organization factory was done, and it was true. And then after the creation of the first prototype of the front end, I would do a revamp, let's say, of the organization factory in order to have less transaction as possible to create an organization, so to spend a less gas as possible. But a couple of days ago, 3 days ago, if I remember correctly, I had a kind of I had a kind of inspiration on how I just how it was possible to keep the organization factory cheaper as possible now in rapid time. So it took me 3 days in order to obtain this goal. The list of the priorities just changed, but everything goes on everything is always on track, because instead of doing the front end, then doing the optimization, and then redoing the front end, I just did the optimization, and now I'm doing the front end. Before to do the front end, I need to create a deploy procedure. The deploy procedure is a script written with the help of Multiverse that will allow me to deploy the new organization factory in smart contracts. I mean, and this is for two things: deploy, of course, and also for the tests of the new organizations, because all the edits that I made need some tests. Some of tests could be done before the creation of the front end. Other tests will be done during the front end development, during the front end first beta release, let's say, and that they are useful in order to find all the bugs that there are in the code. Because usually when I program smart contracts, it took me the most the longest part of the work is not development of the smart contract, but it's finding bugs. And so the development, as I said, for example, can last, the development session can last 3 days, 4 days, but the debugging session could last, I don't know, 2 weeks, 3 weeks, 1 month, in order to be extremely sure that everything works well. It depends of the amount of the work. Luckily, in this phase, there is something that we already tested. So even if you can see to the Git comics, the work was massive, was huge. The reworking was huge, but I touched the only things that just needed let's say a kind of refresh. So nothing that it must be tested, but not so. Sorry. My phone. Okay. So you can. Yes, the most important things to test is the new fixed inflation because it is brand new and it has never been tested and it will be tested a lot before to say okay, I think you can use it. Okay, because in this space we are in beta. Okay, and the other things that I made during these days, so I mean the organization factory and the new chip organization creating system, let's say, was already tested. It's just some edits on the code, but it could be extremely. I I don't want to see that. I don't want to say that I can. End all the tests in a short time because yeah shit happens every time even if you already test something but it could be extremely easy to do the tests of the things that I will show you right now. So last time we discussed about the general purpose fixed inflation management manager, which is of course the new fixed inflation that we discussed together. I think that here I just did a couple of things about the destination, the fixed inflation procedure, but nothing so strong. But I want to show you just for transparency stuff. Let's see. So I changed the name of the funds destined to a company that developed a protocol. Now it is called Bootstrap Fund because it is just for the bootstrap of the protocol in order to be released once the protocol is done. And for this, the Bootstrap Fund wallet can be changed. And also it can be released. So once it is released, the Bootstrap, the company behind the protocol, whatever it is, the protocol of the organization, will stop to receive funds. So it can create a delegation in order to maintain the protocol, the front end, etc. But I did some changes just to be more clear and I don't know how to say more transparent. So okay, so the procedure is written here. The Bootstrap Fund, if you specify a percentage for the Bootstrap Fund and the Bootstrap Fund wallet address is 0, so it means there is a Bootstrap percentage but no address, you can specify a component of the organization that will receive the funds to replace the Bootstrap Fund. So let's say, for example, I am the protocol creator, I am the bootstrapper, I'm just specifying myself as to receive the Bootstrap funds. If I will release the Bootstrap wallet, I can specify a component of the organization that will receive those money. For example, let's say if I want to release the Bootstrap Fund, I would donate everything in a new organization. I mean, not in Ethereum OS. I am the creator of a brand new organization. I release the Bootstrap Fund. I want that my percentage of the fund should go to the treasury splitter, let's say. So the external default component is the key of the treasury splitter manager. So if the Bootstrap wallet is 0, the treasury splitter will receive the money. If both of them are 0, so let's say this is the edit that I made since last time we had a Vasa pill. If the Bootstrap wallet is 0 and the component key, the default component key is 0, then those tokens will be burned. So let's say I receive 5 tokens of the organization, okay, in Ethereum or in raw tokens, because I can specify both, one of them. If I decide to receive raw tokens, they will be burned. So no more tokens so the inflation decreases automatically, because yes, the part of the tokens designated to the bootstrappers would be useless, so it will be burned. Uh, if I as a bootstrap, I decide to not receive tokens uh, raw but Ethereum, and the wallet is always zero, and also the default component is zero. Those Ethereums goes to the treasury of the organization. So in the hands, in the Ethereums, I mean, the Ethereum value goes in the hands of the token holders. That's it. That is the edit that I made. So let's recap. Bootstrap fund, we already described it. Then there is the mint action. Send the tokens to all those components that the organization decides to receive the raw tokens. The part which is not sent as a raw tokens but will be swapped on for Ethereum. The code assures that there is always be even a little part that can be sent to the in Ethereum in order to go to the executor of the transaction. So the percentage goes to the executor, and the other percentage of Ethereum goes to the Bootstrap fund if he decided to not receive raw tokens but just Ethereum. If zero, it goes to the treasury manager, and the other part, the very remaining part, goes to the other components that we decide that they must be receive Ethereum. So let's say, for example, in a fixed inflation, in a new organization, I can choose if I want to send to the treasury splitter, let's say, actually just, or for example, a farming contract to receive raw tokens in order to use the reward as a reward, or just swap all the tokens because I don't know, I don't have a farming contract like the one with its rewards, with the rewards in Ethereum, and all the money go off. If I decide that I don't have a treasury splitter, I don't know, everything goes to the treasury manager in Ethereum. So the structure is pretty dynamic, and you can specify who can receive the tokens and who can receive the Ethereum. So this is the last thing that I edited right here. And okay. Then I started to work to the organization factory. We already had, of course, the organizations factory. We had two factories for organization. The DFO factory, which are with that were rebranded as a root organizations factory, and sub DAO factories for the sub DAOs. So the first thing I did is to use the new chip factory system everywhere. Wherever there was something created with the old cloning system, I replaced it with the new one in order to be cheaper. For example, let's see in the sub-DAO factory, which is the most important right now. Okay, here, okay, model allocation.clone was the old cloning system that just copied the entire bytecode of the smart contract in the new smart contract in order to be used. And I replaced it with the creator new API, which is the cheaper system, which just use a general purpose proxy with the model. So it doesn't copy the entire byte contract, which could be that could be huge and of course expensive to do, but just create a tiny contract that uses delegate call in order to call the code of the model you choose. And this is everywhere. For example, when I create for example, into the fixed inflation factory, which is the old Covenant routines factory, same thing, was cloned, now it is created, and etc. So this is the first thing. And then I created the new organization factory, starting from the sub-DAO factory, which was the most, no, sorry, the DFO factory, which was the new root organization, which was the most complete. I created the new organization factory in order to merge in the same contract the root organization and the sub, if needed, and the sub-DAO organization. As we said, we in the new front end, we will have two kind of organization that can be created: full organization or lightweight organizations. The idea for the full is to have the fixed inflation and, of course, a token that can be mintable and that can be mint in order to let the fixed inflation work. And the second one is the lightweight, that just has the treasury splitter, the common treasury, the delegations manager, and all the things that you want to insert because it is open. And the new system was to use, because of the root in the actual Ethereum SOAS organization, there is the root organization and there is sub-DAO organization, and they are linked. What I did the first thing that I did with the chip factory system, in order to let it be cheaper to create an organization, is not to have root, if any, a sub-DAO, if any, but to merge them. So you can have a sub-DAO, let's say, which is the new organization, okay? If you can attach a root, a model that can you let create general purpose smart contracts, general purpose proposals. So the sub-DAO has fixed proposals like change the investments manager, move the funds, etc. And the root, if you want, you can also have the root that you can release at any time because it has the host. So the first thing I did is to merge this in just one organization, and it was pretty simple because it just needed to change some things inside the code, just a bunch of lines. But this kind of things, as I always said in other Vasa builds, can be done only when you have the big picture in front of you. You cannot see it during programming, because while you are programming, while you are developing, you are solving problems, okay? In this case, that is, and the problem in that phase is to let it work. Let it work, let it work. No, the song is different, but okay. But when you have the big picture, you can see, okay, these things can be done like this, and these things like can be done like that. And this is the first edit I did. Let me see if I can show you. Okay, let's check how the proposals manager work. Okay, the proposals manager work into. This is the original one, the one that is inside the Ethereum SOAS organization. It could manage two modes. Host this proposal command, which is a boolean that can be true or false. If true, that means that this is the proposals manager of the sub-DAO. Just to recap, the proposals that let you change the tokens of the investments manager is a proposal model of a sub-DAO. The OS app is a general purpose proposal that we did because there was a root attached inside your organization. So this means that in the sub-DAO, host this proposal command. Sub-DAO means the one with proposal, the hard cable proposal model. Host proposal command is true. In the root proposal, host the proposal command is false. This means that when host this proposal command is set as true, it means that it can receive proposals just from another piece of code, which is the sub-DAO. And the sub-DAO has a bunch of limited proposals that you can do. So the circuit is closed. When it polls, it means that the rules of the proposals must be general purpose. Okay, and in the configuration where it is the configuration of the general purpose proposal, there is the way to force that the general purpose proposals can be done just by a host. So the host can propose and the token holders can vote and execute them. Okay, in the sub-DAO, the proposal set is limited. Okay, there are, for example, in Ethereum, so as I said, the investments manager change token to sell and to buy, the various fixed inflation parameters, etc. And they don't need, of course, anyone to create. There are not needed special permissions to create a proposal like that. For example, the delegation is just a sub-DAO with a bunch of preset proposal models that in some cases needs that the host is the one that creates the organization. That creates the proposal. For example, to change metadata of a delegation, everybody can, every host can do it, but just the host of the delegation can do that. What to say with this? In the old version, the Ethereum COS version, there must be needed a proposals manager for the root proposal, where host's proposal command was false, and the proposal manager for the sub-DAO, where host's proposal command is true. Just adding these two lines that now I will describe you can have just one proposal model for both root proposals and proposal models. So one proposals manager for just root proposals and proposal models, hard cable proposal models. So this means that you don't have to have an root organizations with his own proposal models linked to the sub-DAO and all the other proposals with their own proposal manager. You just have one organization, which is the sub-DAO, and one proposal manager. So two contracts don't need it anymore. So cutting costs of the creation of the organization, and this is why the first thing I did. So how this works? So if host's proposal command is true, it goes to ask to the sub-DAO to resolve the code sequence, so the proposal that it must be done. So if the code sequence is recognized by the sub-DAO, it means it is the proposal of one of the bunch that I know, that I understand, I recognize, I can create it. If not, in the old version, it would be failed, the transaction. So no one can create in a sub-DAO a root proposal. In the new version, if the proposal is not recognized by the sub-DAO, it maybe could be managed directly by the proposals manager as a root proposal, if any. If not, the work finishes right there. So this can be just a little edit, just this one and this one, these two lines. I just added these two lines in order to save two creations of the transaction. As I said, you cannot realize it until you see the entire big picture. And this is the second thing that I did for to save space. But the most important thing is not that gas optimization on creation. This is the things that I already described. So we had the new cloning system, the new organization factory, the gas optimization as creation. That as I said into the organization factory, yes, I just removed the piece that creates the root organizations and the root proposals manager. Just done, gone, because it is not useful anymore. Because, as I said, in the old version, let me see here. Okay, in the old version, if into the sub-DAO proposal model, the sub-proposal manager, you provide an unknown proposal, it will say invalid model. In the new version, it just returns void code. That means, proposal manager, do your business. This is a root proposal for you. Just manage it as you know. If you're able to do it. If there is no root proposal, even the root proposals manager will fail. But just with an organization. So we have a question. Let me see the question. What about, Matt asks, what about the investment manager and pushing code updates with proposal? Can you be more specific, please? I think that I didn't understand your question. Thank you. Okay, and then we have another thing. So, as I said, at this point, okay, so when I resolved this point, I was going to release the first front end, but there was just something that, as I said, there was not perfect, and that brought me to do this little edits here, to do this, everything, all this code here, which are a lot of massive edits on the code, because yeah, we saved a lot in gas consumption terms, I mean. So we have a new chip factory system, we decreased the number of decreates, but there were a lot of smart contract creations that were totally useless, not because the created contract were useless, but because the fact that they must be created every time was too expensive. And I am referring to all the things that validates the proposals. I mean, for example, you can have a proposal. Let's say, for example, in the investments manager, okay, you must need the 5% of the hard copy in order to be able to, let's say, I'm just giving an example, in order to be able to let a proposal pass. In the case, if I'm modifying the token to buy, the tokens that must be bought for Ethereum. But for example, for the proposal of the token sell, the hard cap to reach must be higher than the token buy. So they must be different. 5% for the token buy, 15% for the token sell, let's say, or less, or nothing. Okay, and all these rules are managed by different smart contracts. I call them the proposal rules validators and executors. So that means for every single sub-DAO proposal, or for any root proposal, there could be different rules for each piece of code, and they are tons and tons and tons of new smart contracts. So let me see if I can. Yeah. Okay. Let's say. Okay. For example. Okay. The code that validates if a proposal can be considered accepted or refused by a quorum. Okay, so if the proposal reached the quorum, it passes. Okay, so where it is so if the sum of the accept or refute votes reaches the quorum and the accept are more of the refuse, the quorum is reached, then the proposal can pass, can be executed. Okay, but the quorum value here is it depends on your custom code. Because, for example, in my group proposal, quorum can be 5%, as I said. In your proposal can be, in your organization can be 15. Okay, and this is the difference. In the old version of the organization, I must create a new validated quorum smart contract for me with my 5%, and one validated quorum smart contract for you as 15%. Also, there could be a difference because my quorum could be a hard cable number. So I need to reach 500 tokens. Okay, as a strong number. In your case, that could be the 15% of the total supply in that moment, and they are different rules. And so this is another parameter that must be inserted inside the new creation of the smart contract. So create a smart contract of quorum for me and for you. Another thing, I have 5 sub-DAO proposals with 5 proposal models. Every of them has different quorum values. Let's say 5%, 50%, 20, 80, etc. Okay, so 5 proposals, 5 smart contracts, 5 creation, more gas that consumed. But you know what? The code is always the same. It's just the parameter that changes, and that is the thing that I did in these days. So passing from a logic that you must create a smart contract per each rules to another point of view. The code is always the same, but the parameters are passed from an external source. So in this case, for example, the validate quorum, I can show you the code proposal validators. I can show directly the code. Okay, so this is the old validate quorum that has a URI in order to read all the information about what this smart contract does, how it does, etc. The value, which means 5%, 50%, and discriminant. True means that value is a percentage. False means that it is just a raw number. Okay, they must be passed during the lazy init. With the lazy init method, that it is the lazy init capable element method described into the Swiss knife documentation. You can go there and write how it works. But it just, and also the label. But the label means that this is the quorum, this is the other hard cap reached, etc. That can be it is always the same for everything. Like the URI is always the same, because the URI contains all the data that let the front end easily draw the graphics of this smart contract. Okay, so that the one that can let you appear the percentage of quorum to reach, etc., into different end. And they are always the same. The only thing that's changed is value and discriminant that in the old version were passed during the creation of this smart contract. So, as I said, if I need 5 different quorums, I need 5 different smart contracts to be created in the same transaction. And for this reason, there was no possible to create an organization with just one transaction, because all these transactions and plus other transactions can be really hard to manage. Can be really hard to manage. And this is what I changed, because in the new session, in the new version, you don't have the label anymore, you don't have the URI anymore, you don't have the value of the quorum anymore, because they are passed as a parameter by the proposal itself. So every time you are trying to validate a proposal in order, does it pass or not, the proposal manager will pass the input data of the quorum in this case. So in the first version of the a proposal model of how a proposal is represented. It doesn't matter in this case if it is a proposal model for sub-DAO or a root proposal. In the old proposal, there are, for example, the where they are proposal. Yeah, there were the creation rules in the case of the proposal. The root proposal, the creation rules or the delegation to change the metadata, the creation rules are those that contains the logic. Am I the host of this organization, of this delegation, in order to propose this? Those are the rules. And that was the only data passed on the old structure every time it was created. In the new version, and this the same thing it does for was for triggering rules. For example, triggering rules are those rules that a proposal can execute before to execute. So when the proposal is ready to be executed, okay, there could be some triggering rules, additional triggering rules that can be executed in order to in parallel with the creation of the organization, or the validators, like for example the quorum is a validator, etc. So in the old proposal version, there was just the addresses created every time. In the new version, there are the same addresses, the can terminates, the validators, the creation, blah blah blah, and the additional data. So this means adding a new parameter into the proposal. Let me do not create every time a new quorum, a new hard cap reaching, a new block length, etc. The code is always the same. I don't need to recreate it. The parameters are different. So for each validator, for each trigger, the trigger is a singleton with no data inside, just the label, which is hard cable and which is always the same, and the URI, which is always the same. And I also will show you how I manage that, because I test something that that I wanted to test for a long time, because it is an idea to hard cable information without the need to recreate the smart contract every time. So in this case, in the old case, the proposal manager just asks to the creation rules if there were the conditions to create the proposal. In the new version, the proposal manager does the same thing, but passing the data. And the smart contract, of course, is read-only. Once it is written, it cannot be changed. So it cannot pass, for example, for the creation rules, the data of the triggering rules, because it could be a fraudulent behavior. The smart contract is written in a way that the creation rules just receive the creation data, the triggering rules, the triggering data, validation rules, validation data, etc., etc., etc. And so this saves a lot of gas costs. Because in this case, for example, for the quorum, we always use the only smart contract that we will create with the creation procedure of the organization that I was writing right now using MultiOS right here. You will find the code on GitHub when I will finish it, and a lot of space and a lot of gas cost is saved. This rule can be applied for the, I think, 95% of the cases. There are some cases where this cannot be possible, of course, but here, guys, trust me that we drastically reduce the cost of the creation of an organization. The cases where this rule cannot be applied is, for example, for the host of the creation of the proposal. Because let's say, for example, I create a delegation with a host wallet, okay, and then I want to change the host. If the data are hard cable into the proposal, I cannot do this because they are hard cable. So in this case, cannot be possible to reuse every time the same address. And just for this little a little set of cases, the old version, so create the new smart contract, is always it can be used. But this, of course, reduces the cost because instead of creating 5 smart contracts, let's say you just create one, which is an enormous, a giant save of gas. Yeah, and for this reason, I created the new proposal rules factory. That let me check. Here, proposal rules factory that lets you provide the models for the quorum, for the hard cap, for the length of the transaction, for the host, etc. And each model has a boolean, true or false, that say it is a singleton or it must be created every time. So, for example, in the case that I made, the quorum is a singleton because you can always use the same code, but just the values are hard cable into the proposal model. So you don't have to create a quorum smart contract every time. The host is not a singleton, so singleton will be false because it must be created every time in order. Why I'm saying this? Because I will show you the code in the general rules here. The host by specific address always have the value and discriminant, and the value can be changed by the old host. So let's say I'm the host, okay, I want to change the wallet, I must do the set value transaction as a whole host in order to change it. Also, if I choose to have the discriminant on true, this means that the host, once set, it cannot be changed anymore. So let's say I am the host. If discriminant will be false, I never can be able to change the host anymore. Or for example, if I specify address 0 a new value, means I am releasing the host. So in this case, for example, this is the trick in order to release the root proposals. I have a root proposal with my host. Okay, so I can in my organization I can create root proposals. Once I set the value of the host of the proposal to address 0, no one can create root proposals anymore. So the organization is closed and fully decentralized in the hands of the token holders. And this is what the creator validator does. Every time a new proposal is created, the check method of these rules is called, and if the from of the who is asking to create a new proposal is different from the actual host of the organization of the root proposals, the result is false, so the proposal cannot be created. So if I release the host, the address 0 is the new value, is the new host, the address 0. So if you are lucky and you find the key of the address 0 wallet, first of all, you are the richest person on the planet because the address 0 is full of money, Ethereum, tokens, etc. If not, okay, you cannot create proposals and root proposals anymore. Or if you release the host of the delegation, you cannot be able to change its metadata or in order to attach to other organizations in the future. And that's it. So this is the general rule that is just a lazy init capable. So it means that it must be created every time. But as I said, the quorum is not doesn't have a lazy init anymore. The constructor is always needed because of solidity constraints, but it's not used when you create. It just used one time. It must be used just one time, and nothing more. And how it works right now? As I said, in the old version, it grabbed the data from the value. Let's see if I can. It grabs the data from the value hard cable in the storage. In the new version, you just use the checker data, which is bytes that contain the value and the discriminant. So the checker data of the creation is the one described here, the creation data, or sorry, the validator data. So you have the validator address, which is the quorum, and the validator data, which is the checker data in the case of the call. So every time the proposals calls check method on the validator of the quorum, it always passes the validator data linked, which are the checker data that contains, of course, the value and the discriminant in this case, which are, of course, the value of the quorum and if it is a percentage or a hard cable value. So now a question could be, at creation times, how can I be able to be sure that the input, because it is a general purpose bytes, how can I be sure that I create an organization with the right valid data? And the response is that in this case, for this case, I created the validate input call inside every validator that say, okay, pass me the data that you want to use for this validator, and I will check if they are good or not. So if you are a bad actor that pass wrong data, the transaction will fail at creation time of the organization. So this can prevent everyone to have a fake organization that can steal money. And this is extremely important. And this is another thing that I did in these days. So what about now? The last thing that I did with this check is that, let me see here, okay, is that in the new organization factory, what I did is this huge piece of code that just grabbed the data from the root proposal, if any, and the all proposal models of the subDAO, if any, collect all the creations rules, all the validators rules, all the execution rules, all the triggers rules, all together, pass them through the proposal rules factory, which is the one that creates and validates your input, and receive back the entire consistent list. So let's say, for example, I have a proposal model which needs the host. Okay, the proposal rules, you pass everything in general purpose way, just in one transaction. It will give you back just and creates just the address you really need, not everything. So let's say, for example, you have 5 proposal models, just one of those has the specific host needs. So it is the only one that will be created. All the other will be not created. And so the gas consumption is really low right now. And that is all the things that I did in these days. So let's say the code is okay. Now there is the debugging part and the front-end part. They, as I wrote on Telegram, they work together. So now on Multiverse, I am preparing the thing that I call the procedure. The procedure is the thing that will be executed on chain. So Multiverse, as you know, is a tool that lets you duplicate fork the network, the Ethereum network, Optimism, mainnet, even a testnet, okay? and to replicate the exact events that will be done into the real chain. So multiverse can be used like this. You create a procedure, okay? In this case, the name of the procedure is organization factory V1. It will contains the entire code that will be used to deploy your procedure. And then after that, you can also choose to test it. So the thing that I'm doing right now is to create the procedure. What this means? Okay, I have to create. I have to. The arriving point is let the people push a button and create an organization. To do this, I need an organization factory. But as I said, to create an organization factory, I need the models of the code of the organizations, all the proposal model, the investments manager, the fixed inflation, all the proposal rules I've already described. So you must start from the scratch. The first thing to create are the proposal rules. Once the proposal rules are created, and these are the proposal rules, you can create the proposal rules factory. After that, you can create all the original smart contracts of the organizations. Then you will attach the factory of the organization, and you completed the procedure. And it can be tested and tested and tested until it works like a charm. And you are extremely sure that what the test says is what the mainnet will say. And once the entire procedure is completed, you can pass to the test. Test the fixed inflation, test the creation of an organization at first, of course, test the fixed inflation, test the creation of a proposal, etc., etc., etc. And as I wrote, all the tests of the little piece contains functions that are written thanks to Multiverse, that you just need to select, copy, and paste inside the different end scripts. So once the tests are completed, you can copy paste them into the front end and you're done. Of course, you need to attach the UI, the comments, the text, etc. But the most important and a huge part of the work is done. So this is what I was going to do right now. In the new repo I just created called organizations tests. It is public on GitHub. It is empty right now because, as you see from the green code, everything is going to be released. I don't know, in the next days, in the next hours. I don't know if I will work more. And that's it, guys. So the last thing I wanted to show, because I mentioned that I wanted to experiment a new thing that I think that worked right now, which is this. I called it the hard-cabled something, hard-cabled info, okay? So in the new versions of Solidity from 0.7, I think, I don't know if 0.6 have the immutable keyword. Immutable keyword means that these variables here are linked inside the code of the smart contract at creation time. Okay, so if I want to create a hard cabled value inside the smart contract, let's say, for example, uint 2564 public constant equals always 10. Okay. Oh, sorry. Public constant full. Now this piece of code is an integral part of the bytecode of the smart contract. So it is saved on the chain, not in the storage of the contract, but in the code, the part saved dedicated to the code. And when it is a constant, it needs a hard cable value. The mutable keyword is the same thing of the constant. So the label, the URI 0, URI 1, URI 2, URI 3, URI 4, are hard cabled inside the bytecode, not in the storage. And it can be used always, even if you clone the contract. But their value can be passed at constructor time. So not this is passed at compilation time. So while you are building the smart contract code, and this is called when you're deploying the smart contract. So they can be used in different phases. What this means that if I didn't use the label value, the immutable keyword, but the constant one, I was forced to insert by hand all the values of the variables, and that cannot be possible because our cable info is used inside, the by-specific address, which is the host one, the hard cable info, the can terminate for the quorum, for example, etc. It is always used, and every time you need to pass the right data. And so this is a new way that I experimented in order to have cloned smart contracts that can bring data from the original. So of course, read-only data, because the immutable keyword means that you cannot edit anymore them, but it's okay because the label of the quorum will be always quorum, for example. But why I didn't save the URI of the metadata or the label as a string, but as bytes 32? Because immutable cannot be used with strings, because the strings are of variable length, while the bytes 32 are our specific length, which is always 32 bytes, as the word said. And so what? For example, if I have a label, okay, the name, by quorum, by specific address, etc., can stay inside 32 bytes, and that's okay. But the URI can be short or long. There is no standard. So what I invented is this: split the strings, this long string, inside multiple bytes 32 pieces, chunks. Okay. Again, I cannot use an array because the array has a dynamic length, so it cannot be immutable. So you can have at least a URI of strings, of a string made at least of 32 multiplied 5 bytes. I don't know the number right now, which is a lot of characters for a URI. Okay. Usually the URIs are written in IPFS, so the length is extremely short. But you can also use you can also use anything that is not, of course, cannot be IPFS. For example, my HTTPS, my long URI extension, etc. And it just I just found this piece of code that from bytes 32 it can convert you as a string. So what you see is what you will do. You will not use this and reconstruct it them by yourself. Just call the URI or the label, and the asString method does the magic. In this case, for example, of the URI, it just creates a string packing all the URIs, URI 0, 1, 2, 3, 4, in just one string. So it reconstructs the entire string. And this is another thing that I did in these days, because as I was writing on Multiverse, okay, you pass the label and the URI in plain, and then just convert to hex in order to have the bytes 32. But the 2hex call of the Web3 utilities just gives you the most important, the significant part of the bytes 32. And with the method fill with zeros, you just add add more zeros until you arrive to the end of the bytes 32 standard length. And the same thing for the URI. I convert the URI to X, and then I will push into the array for 5 times, 1, 2, 3, 4, 5, the substring from 0 to 64 characters. And then shift to the other 64 character and shift to the other 64 characters, etc., etc., etc. So in this case, to create the codes of the proposal rules, I just pass the location of the smart contract, the name of the smart contract, the label, and the real URI, and see if it is a singleton or not. In this case, true means that it is not a singleton in order to create the correct byte code for the smart contract. Once you have the byte codes of all the proposal rules you want to create, just create also the singleton array and call the proposal models factory in order to deploy the entire contract in just one thing. And you create the proposal rules factory that can be also used into the organization factory in order to create the organization factory itself that can let you create the organizations. Everything is managed by the factory of factories, so everything can be managed through a front end in a really transparent way, and that's it. So I want to, next step are finish this procedure and then try to verify if we really are able to create one organization in one huge expensive transaction. But keep in mind that they could be more than one, 2 or 3 really expensive. Just so you just have one expensive transaction to create an organization. I think that is a really good goal, and I hope to reach it. Nothing, guys. I think that this is it, and hope that you enjoyed it. If you have any question, I'm right here for you. So we reached the 1 Vasa pill hour. I hope that I can make shorter Vasa pills, half an hour, not just an hour, because it can result boring. But yes, every time there is a lot of things that I can talk about, so it's okay. Okay, so hope you enjoyed, guys, and thank you very much for watching. See you. Bye bye.